So for 10.3, I'm going to do notes a little bit differently. I am making a video so you guys can watch this online at home on your own time. And you can take notes, you can pause, you can rewind, and you can hopefully get an understanding of something you miss if I go a little too fast at times. And this one, we're going to be working on 10.3, which is finding and estimating square roots. So first of all, you need to remember what a square is. We've gone over perfect squares before, and these are numbers like 1, 4, 9, 16, 25, 49. Those kinds of things where if there are two numbers, it's one number multiplied by itself to equal it. So 1 times 1 equals 1, 2 times 2 equals 4, 3 times 3 equals 9, that kind of thing. So the first example I'm going to go through is simplifying a square root. So we're going to be given two square roots, and I want you to, on a sheet of paper, I want you to find the square roots of these. So number 1 is the square root of 64, and number 2 is the square root of 49. I'll give you some time to work on that, and the answer is not going to appear on the screen, but I will tell you them in a couple of seconds. So I'll give you some time to either pause it or write it down. The answer to number 1 is 8. 8 times 8 equals 64, so the square root of 64 is 8. And number 2 is 7. 7 times 7 equals 49. So pretty much the basic foundation of these is when you split the number apart, you're looking for a number that is multiplied by itself to get your number under the radical, which is that little symbol thing above my 64 and 49. And these two examples above are both positive square roots, meaning they're automatically assumed that their answer is going to be positive since there's no plus or minus written in front of them. So next we're going to take a look at negative square roots. So a negative square root is pretty much the negative sign is outside of the radical, and when you see it, you're going to still find the square root, but you're just going to have a negative in front of it. So with these two that I've given you below, I've given you negative square root of 100 and negative square root of 121. So first you're going to find the square root of 100, and then simply you're just going to put a negative sign in front of it. Same deal with number 4, you're going to find the square root of 121, and then just put a negative sign in front of it. So I'm going to give you a few seconds to either pause the video or quickly jot down the answer, and then I'll tell you what the answer is. With number 3, the square root of 100 is 10, so our answer is negative 10. Number 4, the square root of 121 is 11, so our answer is negative 11. So when we have an expression like this, the negative sign goes outside. And we call ones that have a negative sign under the radical to be undefined. So instead of negative square root of 100 like I had above, we could have the square root of negative 36, and this is considered undefined. So what I'd like you guys to take a couple of seconds to consider, and maybe the whole night, is why do you think that this is not also called a negative square root? There's a negative sign in there, but mathematicians like to call this one undefined. So I want you guys to think about this question in orange or goldenrod, whatever kind of color you think that is. I want you to think about that tonight, and we can discuss this further in class tomorrow. So the ones in pink, 3 and 4, are negative square roots. The one in blue is not. So just kind of ponder that question tonight. Okay, so sometimes we see radicals with a weird looking symbol. You might have seen it before in front of it. It's called plus minus, which is literally a plus sign above a minus sign. And when we see that written in front of a radical, it means it could either be positive or negative. So when we go to write our answer, it's also going to have the plus minus in front of it. So I'm going to give you two examples below, and they're going to have the plus symbol written in front. And when you go to simplify these, you're just going to write plus minus in front of your answer. So for number 5, you're going to find the square root of the positive and negative square root of 9 over 16, and then the positive and negative square root of 25. Just a reminder, with number 5, you take the square root of 9, and then you take the square root of 16 with your fraction individually. So just like before, I'm going to give you a few seconds to work this out on a piece of paper or to pause the video so you can write down your answer. So on number 5, our answer is plus minus 3 over 4. And that's because the square root of 9 is 3 and the square root of 16 is 4. With number 6, our answer is plus minus 5. So right here, we're just keeping that plus minus symbol in front. So now I'm going to talk about classifying radicals. When we can find the square root of a number and it terminates or ends and doesn't go on forever, it is called rational. So with rational square roots, these are the square roots we are all familiar with. The square root of 36 is 6, and that terminates. And I'm going to give you some examples below. So the plus minus square root of 81 is plus or minus 9. 9 is a number that ends. Same thing with the one below. It looks a little different. It's the square root of 1.44. But if we were to take 1.2 and multiply by itself, we'd get 1.44. So even though it's a decimal, it ends at a certain spot and doesn't go on forever. And these are called rational, which means they have an ending point. The other kind of classification we can have is irrational. And this means that the numbers to the right of the decimal place will go on forever and they never end. And they never repeat either. So they're non-repeating, non-ending numbers. So an example of this would be the square root of 5, which is about 2.23606797. So none of those numbers are repeating, and I cut it off at a certain point because I didn't want to write this forever. And so it would go on forever. So we would just need to know that this one is irrational. So finally, the last thing we can do with our square roots is we can estimate a square root. So if we're given a number and we can't tell the square root of it, we can tell what numbers it's between. So our example below is between what two numbers is the square root of 14.52. So first of all, the first thing we need to think of is what is a number, a perfect square that is less than 14.52 and a perfect square that is greater than 14.52. So then the perfect square that is less than 14.52 is 9, and the one that is greater than 14.52 is 16. So then I rewrote it as the square root of 9 is less than the square root of 14.52, which is less than the square root of 16. So now what I'm going to do is I'm going to simplify my two radicals on the end. So I get 3 is less than 14.52, which is less than 4. So that tells me the radical of 14.52 is in between 3 and 4 somewhere. And right now at this point, all we need to know is that it's between those two numbers. So my answer would be between 3 and 4. So I hope this video was helpful to you guys. I'll take suggestions on what I can improve, if you liked it, things like that. And I'll go over this some more tomorrow. So if there are some things you got stuck on, questions you have, we can discuss this in class. Make sure you also jot those down on a piece of paper. And I hope this lesson wasn't too confusing for you guys.